Welcome. It is Friday, September 11th, and today we wrap up transformations by looking at reflections. So reflection is when we take a function and we flip it, or we flip it sideways. So let's get started. So today we're going to perform the following transformations, reflections. So we have two types of reflections. We have one where we flip it over the x-axis, that would be a vertical reflection, and one that we flip over the y-axis, which is a horizontal reflection. So if this is our original function here, 2, 4, and I flip it over the x-axis here, all right, what I'm doing, that would be considered a vertical reflection. And if you look where the negative is, it's outside the function. Anything that's outside the function is always going to be dealing with something that has to do with a vertical aspect of the graph. In this case, the vertical flip. All we're doing is we're taking the y-coordinate and we're multiplying it by -1. All right, if we flip over the y-axis here, all right, then we're taking the x value and we're multiplying it by -1. So that's reflections. So if I was going to reflect the graph, all I'm going to be doing here is taking this graph and taking the x-coordinates or the y-coordinates depending on the flip. So when the negative is outside, we're going to take our y-coordinates and we're going to multiply by -1. All that's going to do is take it and flip it over the x-axis. And each y-coordinate would get flipped like that. Okay, if it's on the x-axis, then when you flip it, it remains there. And our graph would end up looking something like this, symmetric with respect to the x-axis. Now, if the negative is on the inside, then it's going to be a reflection over the y-axis. So it flips over here, this flips over to here. This is on the y-axis, so it's not going to change direction. And I'd have something like that. So reflections are pretty straightforward. All right. The thing to remember, which is true on all of these functions that we've been working on, is when something is on the outside, it has to do with a vertical aspect of the graph. Okay, so that means it's going to affect the y-coordinate. If what's happening is on the inside, then it's going to reflect, it's going to be something that has to do with a horizontal aspect. So I'd be multiplying the x-coordinates by -1. Okay, so there's a summary of what we've just talked about. This is on the outside, so it's a vertical reflection, and it's going to be over the x-axis. The way I do it is I take the y-coordinate times -1. So if I had the point 4, 3, it would end up 4, -3. When the negative factor is on the inside, it's going to be a horizontal flip, right to left. That means it's going to reflect over the y-axis, so I take the x-coordinates and I multiply by -1. So the point 4, 3 would reflect and become -4, 3. Okay, so here's just an example of a reflection. The orange graph was the original graph. The negative was on the outside. So we can see that the blue graph, which is the reflection, was obtained by flipping the orange graph over the x-axis. Okay, so if I want to get the reflection of a graph, all I'm going to do is just take each point, whichever the distance it is from the x-axis, I'm going to just repeat that, but on the other side. So that one is 5 spaces away, so -5. 3 spaces away, -3. 3 spaces away. And this is on the x-axis, so it's not going to move. And then there is my reflection. When it's inside, now it's going to flip right to left. Inside means it's going to be reflected over the y-axis. So now I'm finding the distance a point is from the y-axis and then just flipping it over. So that one was 6, so now it's -6. That's 4. That distance is 4, so now it's -4. This length is 2, so it's -2 and 0. And then I sketch my graph. Okay, now when you have more than one transformation, okay, you're going to do anything that involves the multiplying first. So we're going to first reflect this. So we're going to reflect it over the y-axis. And then I'm going to slide it 1 up. Okay, so first thing I'm going to do is reflect it. Okay, so there it is, flipped over the y-axis, and now what I'm going to do is just take that entire graph and slide it 1 space up. And then there's my solution. Okay, my next one, I'm going to first flip it over the x-axis. And then slide it 1 space up. Okay, so this point is on the x-axis, so it stays. This point would reflect above it. This stays. This wouldn't reflect below it, and that one would stay. And then I'm going to take this whole graph and add 1 to it, which is just going to take it and slide it up. And there's my solution. Okay, so if you had a point -12, 7, and it lies on the graph of f of x, you want to determine the coordinates on the transform graph g of x. All right, so part of this is what we did yesterday. So I wanted to get some extra practice doing that. Okay, we've got a -3 in here. So that negative is inside the parentheses. So we know that we're going to flip. This is going to be a flip over the y-axis. So we're going to reflect over the y-axis. That's happening first. And then the 3, that is bizarro world. So think about multiplying by 3, and you'd think it would get farther from the y-axis, but it's actually going to get closer. So this is going to be a horizontal shrink or squeeze by a factor of 1/3. Okay, and what I'm referring to is this right here. The 3 is inside the parentheses. Okay, 3 is greater than 1, so it's going to be a horizontal shrink by the graph of the factor 1 over whatever it was. So it was 3, so now it's 1 over 3. Okay, to do that, we're going to multiply the x-coordinate by 1 over 3, and we can do it at the same time with the negative. So here, what we're going to do is we're going to take each x-coordinate times negative 1/3. Okay, so negative 1/3 times 12, negative 12 is positive 4, and the y-coordinate is unchanged. All right, now the next one, this is working on two different variables. Okay, this negative on the outside is going to reflect over the y, or I'm sorry, reflect over the x-axis. And then this 1/3, that's less than 1, greater than 0. It's inside the parentheses, so that's going to be a horizontal stretch by a factor of 1 over 1/3, which is 3. So this is going to be a horizontal stretch by a factor of 3. All right, so we took on this problem right here, the negative on the outside is going to flip it over the x-axis. So I multiplied each y-coordinate by negative 1. So the 7 became negative 7. All right, and then the 1/3 on the inside. All right, so that's 1/3 times x is going to be a horizontal stretch, because p is between 0 and 1. It's inside the parentheses there. Okay, so that's right here. And that's going to be a horizontal stretch, and I'm going to multiply it by a factor of 1 over p. Well, 1 over p is the reciprocal of this. Okay, and the reciprocal of that is equal to 3. So I multiplied the x-coordinates by 3. And I got negative 12 times 3, negative 36. All right, our next one, the negative is on the outside. Okay, so that's going to do the same thing as we did right here. We're going to reflect over the x-axis. Okay, we're going to do that by multiplying the y-coordinate by negative 1. So this is going to be negative 7. The 2 is a vertical stretch. So that's also going to multiply the y-coordinate. Okay, so the y-coordinate actually ends up getting multiplied by negative 2, and it would end up being negative 14 then. And the x-coordinate would remain unchanged. All right, so our last one, we have a negative inside the parentheses, which means that negative 1 is being multiplied, the input's being multiplied by negative 1. All right, that's going to multiply the x-coordinate by negative 1, which is going to flip it over the y-axis. So my negative 12 original point will go to 12, and then this 1/2, which is outside the function, means it's going to vertically shrink the y-coordinate by a factor of 1/2. And that would make my y-coordinate 7/2. Okay. All right. So for today, this will be our last assignment. Is Math Excel 21 transformations. And I'll see you next time. Take care.